Good morning, class. Here's the second part of the final exam review, which is comprehensive, covering from section 1.6 to 5.4. And here's the pledge for any exam, including the final. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. In other words, you take the exam and no one else. All right, we're going to continue with what we were doing. Substitution method is in order. Whenever ln x is involved, that is the choice of u. Its derivative is 1 over x, which makes du 1 over x dx or dx over x. So you rewrite this so it becomes clear. This is u squared, and this one is du. Therefore, the power rule is in order 1/3 u cubed plus a constant. You replace it, and you're done. Whenever you have a rational expression or a fractional expression, in other words, this one is not a rational expression because the numerator and the denominator are not polynomials. But nevertheless, the first step is, can I simplify it? In this case, the answer is no. Notice the derivative of the bottom is the top. In other words, e to the power of x is itself. E to the power minus x is e to the power minus x times -1. So if you choose u to be the denominator, the top times the top is the derivative of the denominator, the top times dx is du. And we rewrite it. So it becomes clear that we have du over u, and the integral of du over u follows the natural log, and it becomes natural log of u plus a constant. You replace the u. Needless to say, since this expression is positive, you could lose the absolute value sign and go with the parentheses. That is your choice. We want to integrate this, and the very first thing we notice, theta is the independent variable. Therefore, for 5, we get 5 theta. Cosine, the derivative is negative sign, but the integral is positive sign. So plus 2 sine theta and a constant. Anytime exponential is involved, the exponent is the choice of u. Its derivative is 5x to the power of 4. Therefore, du is 5x to the power of 4 dx. And so if that is the case, we're going to move the x to the power of 4 so it becomes clear everything is in order except number 5 is missing. And number 5, everybody, you can put it in and undo it with its reciprocal. Although you can solve for dx, this is the best course of action. So we have 1/5 the integral of e to the power of u du, which is itself and a constant. Replace the u. 1/5 of e to the power of x to the power of 5 minus 2 plus a constant is the final answer. Natural log, that's the choice of u. If you want to take the derivative, you get 1 over x plus 1. You have to write the reciprocal of the argument and times its derivative, which is 1. So simply 1 over x plus 1. That means du is 1 over x plus 1 times dx. We're going to rewrite this so it becomes clear that we have u du. By the way, dx over x plus 1 or 1 over x plus 1 times dx makes no difference. Now, the integral of u is half of u squared. What are the new limits? If I put 0 in here, I get ln 1, which is 0. If I put 1, I get ln 2. So half of u squared, you plug in ln u minus 0 doesn't do anything, so half of ln squared is the final answer, everybody. Sinusoidal functions. If the argument involves a function of some variable, in this case, x squared is a function of x, then the choice of u is that its derivative is 2x, which makes du 2x dx. We're going to rewrite this by moving x next to dx. Number 2 is missing. We can put the 2 and its reciprocal 1/2. Again, as I've mentioned many times before, you could solve for dx as they do in many texts. I think this is a better methodology and it's easier. So this is now 1/2 sine of u du. The derivative, remember, is cosine. The integral is negative. The integral of cosine is negative. So negative 1/2 cosine u and a constant, and replace it with x squared, and you are done. In this case, when we have sine as well as cosine, the one that has the exponent, in this case, sine x as the exponent, that's the choice of u. Of course, without the exponent. And having said that, we differentiate, we get cosine x, so du is cosine x dx. So you're looking at u squared du, which is 1/3 u cubed and a constant. You replace it and we are done. 1/3 sine cubed x plus a constant. What if cosine has the exponent? Then cosine is the choice of u. Its derivative is negative sine x, which makes du negative sine x dx. So when we look at this one, minus sign is missing. We put the negative next to it and negative out because the product of two negative signs is positive. Or you can say the reciprocal of negative one is itself. And so you have minus the integral of u to the power of 20 du, which is negative 1/21 u to the power of 21 plus a constant. Replace the u with cosine, and we're done. Many fish grow in a way that is described by the von Bertalanffy growth equation for a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters. This equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years, and rounded to 1 decimal. So this represents the rate, the growth rate, the derivative. So there is a function that should represent the length. So let's call it L of x, represents the length of a fish at hx. Then the growth rate, meaning L prime of x, or dl dx, is this one, with the initial value L of 0 equals 1 centimeter. This is the initial value, everybody. As you know, this is also known as accumulated change theorem or net change theorem. So the amount of increase over the course of 4 years follows that and becomes the integral of a to b f of x dx. So the integral of, for the first 4 years, 0 to 4, and f of x is 29 e to the power minus x dx. So the integral is negative 29 e to the power minus x, and we evaluate it from 0 to 4 because for e to the power minus x, the answer is itself divided by negative 1. So you plug in the upper limit, you plug in the lower limit, you put it into a calculator, and you get the answer. However, we remember L of 0, the initial value is 1, they add up. And so L of 4 is the sum of the two. And since we want to go with 1 decimal, 4 next to it is 6, goes up to 5, 29.5. Because this is centimeters per year, this must be in centimeters. Now, we could use the general form rather than a definite integral. Let's do indefinite integral. And we have the answer. This is the answer plus a constant with the initial value L of 0 equal 1. This will help us find the constant. So plug in 0. This is obviously 1, so negative 29 plus what number is 1? That would be 30. Now, how long will it be when it's 4? L over 4, and you get the same answer as we got here. Needless to say, you go with 1 decimal. The advantage is that if somebody says, okay, let's also find how long the fish is after 5 years, 7 years, 10 years. So all you have to do into this equation goes the numbers that they ask us. Okay, so it makes it, in essence, a tad easier. But either way is fine. The distance in meters of an object from a starting point is given by S of t, the position function 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4? This is telling us use the average velocity because 2 points in time is given. So S of t sub 2, that means S of 4, minus S of t sub 1, that means S of 2, and it's 4 minus 2. So into this function, 2 times 4 squared minus 5 times 4 plus 40, minus plug in 2 times 2 squared minus 5 times 2 plus 40 over 4 minus 2, which is 2. This is 16. So we have 32 minus 20 plus 40, which is 52. We have 4 here. 8 minus 10 plus 40, which is 30. 52 minus 38 divided by 2, 7 meters per second. So that's elementary algebra. And now let's do calculus. What is the instantaneous velocity and acceleration? And specifically after 6 seconds. As you know, v, the instantaneous velocity, v of t is s prime of t. So it's 4t minus 5. After 6 seconds, 4 times 6, 24 minus 5 is 19 meters per second. Acceleration is the second derivative of the position function or the first derivative of v, which means a of t is v prime equals s double prime. If I differentiate, I get 4, and the units are meters per square second. The meters per square second is because this is dv dt. So this is meters per second per second. And because it's fixed, it's not a function of a time. After 6 seconds or 5 seconds or 10 seconds makes no difference. It remains unchanged. When does the object reach a velocity of 31? So velocity is 4t minus 5. Set it equal to 31 and solve for t, which means we add 5, we get 36 divided by 4, t equals 9 seconds. Use differentials to approximate cube root of 63.5. In other words, f of x plus delta x is f of x plus dy. That's the idea. So first you need a function. The function should represent the operation. So all you have to do, read cube root of, that means the function must be cube root of x. Also, we need a number that we know the cube root of, and its closest number to 63.5, obviously 64, because cube root of 64, everyone should know it's 4. Now, delta x or dx is the difference between the two. 63.5 minus 64 is negative 0.5. It's important to understand the meaning of it. Cube root of 64 is 4. Cube root of 63.5 must be less because this is negative, and it's important. For example, if we had cube root of 65, then dx would be positive 1, okay? Because it would be 65 minus 64. So this is what we want to find. We have f of x, we don't have dy. We're going to find dy by differentiating this guy first, which means we're going to write it as x to the power of 1/3 to use the power rule on that. 1/3, x to the power of 1/3 minus 1, which makes it negative 2/3. We rewrite this as 1/3 cube root of x to the power of 2, and dy is exactly the same thing times dx. So now we are in business. So we want cube root of 63.5. That means f of 63.5. That means f of 64 plus negative 0.5, which means replace the x with 64, dx with negative 0.5. Cube root of 64, everybody knows is 4. So this is 4. So this is 16. So we have 4. Plus and minus is minus. 0.5, I'm going to change it to 1/2. 3 times 16 is 48. And the reason I'm changing it because I want to deal with complex fraction. This is 1/2 times 48 or 1/96. And 4 minus that is 3 and 95 over 96. I want you to see the fractional format. And I go to the decimal representation because if I put this into a calculator, I'll show you how close they are. If you stop at 5, you have to change it to 6. The same thing. So if you stop at 5, you have to change it to 6. That's how close they are. And the reason they are close, because the x or delta x is extremely small compared to the choice of x. We're done with that, but I want to remind you, linearization means find the equation of a tangent line. And if we use that, we will get exactly the same answer. So what function? Cube root of x. At what point? X equals 64. So if I put 64, I get 4. So the pair, I want a tangent line for this function at 64, which gives me the pair 64 comma 4. Now if I put 64, so that's what I want. Okay. Tangent line for f of x equals cube root of x at x equals 64. So you put the 64 into the original function, you get the pair 64, 4. If I put it here, I showed that this is what? 4 squared 16 times 3 is 48. So 1/48 is this slope. And I'm going to use the point slope. I don't have to even memorize the limits. Y minus 4 equals m 1/48, x minus 64. This is 1/48, x minus 64/48. Move the negative 4, make it positive 4, and it becomes y, also known as L of x, the linearization or the tangent line, 1/48x plus 8/3. Now, if you replace the x with 63.5 and keep it as a fraction, you will get exactly the same answer here. When I say fraction, it's 1/48 times 63.5 plus 8/3. And you'll see that you get the same answer. Find the absolute max and mean for this function in the closed interval of -4 to 1. And we can use the extreme value of closed interval theorem. Let's first justify that. This function is a polynomial function. Every polynomial function has a domain from negative to positive infinity. This is more specifically a polynomial of degree 4. So the domain is all real numbers from negative to positive infinity. So if it's continuous from negative to positive infinity, it's continuous in the given interval of negative 4, 1. And the extreme value or closed interval theorem can be applied. So we want to go with the first step, CPs. That means find f prime, which is 4x cubed minus 36x. Because we want to set it equal to 0, we're going to factor the 4x out. And this one is x plus 3x minus 3. And if you set this equal to 0, you get x equals 0, x equals minus 3, x equals positive 3. Also, we look at f prime dne. F prime does not exist, doesn't produce any solution because f prime itself is a polynomial, more specifically, a polynomial of degree 3. So it exists everywhere. So there are two answers. Is 0 in between? Yes. Negative 3? Yes. What about 3? No. 3 is outside, and therefore you can only use negative 3 and 0. It's an element of the given interval. So we go back to the original function and evaluate it at the two endpoints as well as the two critical points. So with negative 4, when we plug in, we get negative 4 to the power of 4 minus 18 times negative 4 quantity squared. This is 256 minus, y minus, this is positive 16 times negative 18 is negative 288, and we get negative 32. What about negative 3? Because the exponent is even, we get 81 minus 18 times 9, which is 81 minus 162, which is negative 81. If I plug in 0 here, I get 0. If I plug in 1, I get 1 to the power of 4 is 1, 1 to the power of 2 is 1. So 1 minus 18, negative 17. All numbers are negative except 0, so that is the absolute max at 0, 0. This is the absolute mean at negative 3, negative 81. Your writing depends on how they want you to write it, okay? We want to evaluate the integral of 3 to 4x squared of 25 minus x squared. This is 25 minus x squared to the power of 1/2. 25 minus x squared is a polynomial, so is x. Because 25 minus x squared is more complicated, that is the choice of you. The derivative is negative 2x, everybody, which makes du negative 2x dx. So let's move things around by moving x here and comparing it to du. We see everything is in order except negative 2. And instead of solving for dx, you can do that. I'm going to put the negative 2 that is missing and undo it with its reciprocal negative 1/2. And now we are looking at negative 1/2, the integral of square root of u du, and we discuss the limits shortly. This is u to the power of 1/2. So this remains, and the integral of this is 1 over 1/2 plus 1, u to the power of 1/2 plus 1. 1/2 plus 1 is 3/2, which makes this one 2/3. The product of these two is negative 1/3. U to the power of 3/2. Again, I'm going to discuss the limits in a moment. However, you can always go back to the original. Namely, 25 minus x squared is replacing u, and original limits 3 or 4. So how do we find the new limits? If I put the 3 here, 3 squared is 9. So 25 minus 9 is 16. 16 is the lower limit. If I put the 4, 4 squared is 16. 25 minus 16. The upper limit is 9. And I'm going to evaluate it with those values. 9 to the power of 3 halves, 16 to the power of 3 halves. 9 is 3, cubed is 27, 16 gives you 4, cubed is 64, their difference is minus 37, the product positive 37 thirds. The radius of a blood vessel is 1.4 millimeters. A drug causes it to change to 1.3. Use differentials to find the approximate change in the area of a cross section, which is a circular shape. We should recognize that. And it's going to have some radius. More specifically, it's 1.4 for us. Then using medication makes it become smaller. So we have a new, or more specifically 1.3, the radius has changed. There's a difference between these two, which we call dr. So we have r equals 1.4. dr is the difference between the two, 1.3 minus 1.4, negative 0.1 millimeter. We want to approximate the area of the shaded region. The formula for the area for a circle is pi r squared. So because we want to approximate it using differentials, we want dA. So this is the explanation of the question symbolic. So the shaded region, we want to approximate it. So having said that, we know f prime is dy dx, therefore a prime is dA dr. And if dy is f prime of x times dx, dA must be the product of these two, a prime of r dr. So we're going to find a prime of r, and then we get to dA. To do so, we know a is pi r squared, and dA dr starts with pi, which is a coefficient or a multiplier, and then we're going to differentiate r squared, which is simply 2r. So it's 2 pi r. And so dA is 2 pi r dr. Replace the r with 1.4, dr with negative 0.1. Of course, the units will be the units of the area. Okay, you can see this is 1.4 millimeters. This is also negative 0.1 millimeters. The product gives us negative 0.28 pi millimeters squared. This is an exact answer, roughly, if you want to put it into a calculator with a bunch of decimals. You want to pay attention to how they want you to represent that. So how many decimals? What does it mean? The area of cross section, the area of the cross section of the vessel is decreasing. Why is it decreasing? Because this is negative. By how much? By this much, 0.28 pi millimeters squared. When we mention decreasing, we don't write the negative anymore. However, can I have the exact answer? And the answer is yes. We call that delta A. What is the exact answer? It's very simple. Find the area of each circle. Their difference is the answer. A smaller pi r squared. The smaller one put 1.3 calculated. The larger one put 1.4 calculated. The difference, and I'm going to factor the pi out. I get pi times 1.3 quantity squared minus 1.4 quantity squared. And if you look at this answer, it's very close to this, negative 0.27 pi millimeters squared. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram. Find the maximum area. Well, define your variables. X represents the width, Y represents the length, A, which is the objective function, we want to maximize it, and it's equal to X times Y. The constraint is we have 240 feet of fencing. We notice this side is X, this side is X, and we have three of those. This side is Y. We have only one of them because this side doesn't need anything. So 3X plus Y must be 240. That's the constraint. A is a function of two variables. We solve for Y. We put it into this, and now A becomes a function of one variable. Instead of A, we're going to call it A of X. X represents dimension and must be positive. So X must be larger than 0 on the one hand. On the other hand, how large can it be? If you said 240 minus 3x equal to 0, x becomes 80. And if you choose x to be larger than 80, this expression becomes negative times positive is negative. Area can't be negative, so it's between 0 and 80. And so now, let me erase my work. Now we're going to distribute to get it ready for the next step. I want to find A prime because I'm looking for critical points. So I get 240 minus 6x. And because I want critical points, I set it equal to 0 and I get 40. And since I have an open interval of 0 to 80 with one critical point, local becomes absolute. Now, is it max or mean? I don't know yet. I will do either the first or the second derivative test. Obviously, second is easier. I get just minus 6. This is always negative. You have to plug in 40, but it's independent of x. It makes no difference. It's always negative concave down. Maximum occurs because the shape of a concave down looks like that, everybody. So the maximum occurs when x is 40. Now 3x plus y is 240. So if I plug in 40, I get 120. Subtract it from 240, y becomes 120. And so the dimensions are 40 by 120. The area is the product of the two, 4,800 square feet. We want to integrate, and I want you to see both questions side by side because we want to compare and contrast. Number one, any fractional format, whether it's a rational or not, and in this case, they are both rational functions. You have to simplify if you can. And so the denominator, because this is a prime number 2, is 2x and x, and this is a prime number 1 and 3, one of them negative, you can easily factor it. And that's fine and dandy, but the numerator cannot be factored in part A, so the denominator is a choice option. Its derivative is 4x plus 1, which makes du 4x plus 1 dx. We put the dx next to the numerator, and we want to make sure it's clear to everybody that we are dealing with the integral of du over u. Following the format, we get a natural log, and we say natural log of u, absolute value of u plus a constant. We replace it. We get natural log of 2x squared plus x minus 3 and plus a constant, and we are done. So why are we looking at two questions side by side? What is the difference between the two? Well, the numerator can also be factored out, which means now I can get rid of the common factor of x minus 1. So I deal with the integral of 4dx over 2x plus 3, in which case denominator is a choice of u, and it can't be simplified any further. And du is 2dx. Notice the top is 2 times 2dx. Okay, so you keep the 2dx in, 2 out, makes no difference. You don't have to, as long as you recognize 4 is 2 times 2, you're in good shape. So we have 2, the integral of du over u, which is again a natural log. So 2 ln of absolute value of u plus a constant, replace it. And 2 ln of absolute value of 2x plus 3 plus a constant is the final answer. And we are done, everybody. Now, if I have the reciprocal of this, I have to do long division. If I have a reciprocal of that, since I could factor it, I get the reciprocal of this. And I don't need substitution. This is half of x. This one, 3/4. And x gives you half of x squared, with this is 1/4 x squared, 3/4 x plus a constant, and you're done. That's simple, everybody. G of x is a piecewise defined function half of x plus 3 when x is less than -2 and x minus 1 for x larger than or equal to -2. Is G of x continuous at x equals -2? Why or why not? That means justify. That means an answer is not good enough. Reminding everybody, by definition, continuity means limit of f of x as x approaches a equals f of a. That means you look at the functional value and you look at the one-sided limits. The two must be identical. Now, first, why at x equals -2? Because this is a piecewise defined function, everybody. So the top is a linear function and it's continuous from negative to positive infinity, which makes it continuous from -infinity to -2. The bottom is also linear, continuous from negative to positive infinity, which makes it continuous from -2 to infinity. So you look at the endpoints starting with the functional value. You look for the equality, so you use the second piece. Plug in and you get -3. Now the left side limit, you look at less than, so you use the top piece. So limit of g of x as x approaches -2 from the left equals half of x plus 3 evaluated at x equals -2. Plug in and you get 2. The right side limit, x must be larger than -2. So this has the larger sign, so you go use the second piece. So the limit of g of x as x approaches -2 from the right is x minus 1 evaluated at -2, which becomes -3. As you can see, left and right have different values. The limit doesn't exist. So the limit of g of x as x approaches -2 from the left and right are not equal. The limit of g of x as x approaches -2 does not exist. And g of x is therefore not continuous at x equals -2. Now, and we're done with that, but is this continuous at x equals -2 from the right? I hope you recognize that the functional value and the limit from the right are the same. So the answer is yes, because these two are the same, but it doesn't change the fact that the function is not continuous at x equals -2. Okay. We're going to look at the limit of g of x as x approaches 2 for the given graph function. That's why we look at one-sided limits. So we are going to look at 2 from the left, which puts us in this branch, giving us the y-coordinate 3. That's the limit. So the limit of g of x as x approaches 2 from the left is 3. Now the limit as x approaches 2 from the right, we move towards 2 from the right. That means we are in this branch. That means the answer is 1. Since they are different, the limit of g of x as x approaches 2 does not exist. We want to do the same thing with number 5. That's why we look at the one-sided limit. And notice the limit of g of x as x approaches 5 from the left and right we move towards the same point with the y coordinate 2. So the limit of g of x as x approaches 5 from the left and 5 from the right are both 2. Therefore, the limit of g of x as x approaches 5 does exist and it's equal to 2. There is no dot here, but what is the meaning of this? Assuming this is 1.4, the meaning of this is g of 5 is 1.4, which is not equal to the limit. Now, reminding everybody as far as continuity, if the limit and functional value are the same, the function is considered continuous at that point. Now, number 5 can be fixed. It's called removable discontinuity because the limit exists. When the limit exists, we can fix it. G of x can be continuous at x equals 5 if we redefine g of 5, which is 1.4, to be equal to its limit. But number 2, besides the fact that g of 2 is undefined and it really doesn't matter, it's a jump. There is no way we can fix the jump. So it's not removable. And that's the end of this too. What about this graph? You want to find the limit of this function, this graph, as x approaches 2. From both sides is moving down to negative infinity. Limit of r of x as x approaches 5, both sides of 5, blows up to positive infinity. But negative 3, it depends. The limit of r of x as x approaches negative 3 from the left side, so from the left side, goes down to negative infinity. The limit of r of x as x approaches minus 3 from the right side of minus 3 goes up to positive infinity. Now, to find vertical asymptotes, we have a specific definition in calculus which indicates the limit of f of x as x approaches a, or a from the left, or a from the right, if it's negative or positive infinity, gives rise to the equation of a vertical asymptote x equals a. So with that being the case, this means x equals 2, this means x equals 5, this means x equals minus 3, and this means the same thing, x equals minus 3. Those are the VAs, vertical asymptotes. X equals 2, x equals 5, x equals negative 3.